In this video, I'll show you how to solve the ALEKS problem called ordering numbers with positive exponents. This problem is going to give you three relationships, and it's asking you to choose whether the left side is less than the right side or greater than the right side, or if the two sides are equal to each other. And this problem is going to help us practice a few different properties of multiplying numbers with exponents. So the first problem that we're looking at, all of the terms, or both of the terms on the left-hand side have the same exponent. They're both being raised to the 2. So anytime we have two numbers with the same exponent, I'm just going to rewrite this. If we have 2 to the 2 times 3 to the 2, what we can do is combine the non-exponential part of the number together. So we can say 2 times 3, combine that together and raise that to the 2. That's just one of the properties that we have of multiplying numbers with exponents if they share the same exponent. So maybe I could write it like this: a to the x times b to the x is equal to a times b raised to the x. 3 times 2 is 6, so if we do the math out on the right hand side, that's 6 squared, and that is exactly what we have on the right hand side of this equation here. So for this equation, the left side and the right side are equal to each other. Now the second one is a little bit different. So for the second one, we have our numbers are the same, but the exponents are different. So we're going to use a different rule for that. I'm going to rewrite this problem. We have 2 to the 3 times 2 to the 2. When the non-exponential portion of the number is the same, but the exponents are different, the way that we work the math out on that is we keep that non-exponential portion of the number, the 2, and we add the exponents together. So in this case, 3 plus 2. And that is equal to 2 to the 5th. So again, we have an equality. And I'll go ahead and write that rule, the rule that we used right here. I'll write that over here on the side as well. So this says that if we have x to the a times x to the b, then that we can simplify as x to the a plus b. Now the last one is a little bit trickier because this one we have different exponents and we also have different non-exponential numbers. So I'm going to put this problem right here, 2 to the 3rd times 3 to the 2. And there isn't really a way for us to deal with the left-hand side of the equation. One thing that you could do, if you have a calculator, you could just do the math on that, see what these two numbers are. You could plug this into the calculator, see what you get. We're going to kind of do it like the long way. So since we can't really do anything with this side of the equation, what instead we're going to do is work on this side of the equation, and we'll use this rule right here. So we have 6 to the 6, and we know that if we can find two numbers, a times b, that are equal to 6, for example, 2 times 3, which are equal to 6, we could rewrite this portion of the equation. So instead of saying 6 to the 6, I can write this as 2 times 3 to the 6. So I'm just rewriting 6 as 2 times 3. It doesn't change anything about it. And once I have written it in this form, which matches this form, I can actually separate the 2 and the 3 and the exponent all out, kind of expanding it out. So that gives me 2 to the 6 times 3 to the 6. And we're comparing that to 2 to the 3 times 3 to the 2. 2 to the 3 times 3 to the 2. Mixing and matching my x's and my dots. So we can see right away that this side of the equation is not equal to the other side of the equation. 2 to the 3rd is much less than 2 to the 6th. 3 to the 2nd is also much less than 3 to the 6th. So we're going to be using the less than symbol because this side of the equation is much greater than the left side.